Okay, so we're going to be talking about Unit 12 series, the binomial theorem to start off these Unit 12. Okay, so what is a binomial theorem? The binomial theorem is basically an algebraic explanation of the expressions of the powers of binomials. So it's a way to write the expression of binomials to a certain power. And this is the standard form that you'll usually see binomials expressed in, where the binomial theorem will deal with them in or through. So you have open parentheses a plus b, close parentheses to the n, where a and b are binomial coefficients. So a and b, the standard form can be changed in any whatsoever, but what stays true is your a and your b being coefficients and your n being to some sort of power. So why is the binomial theorem needed? It basically helps to shorten the time spent on expressing a polynomial. You really don't want to take too much time over, doing it by the long way, where it's like, taking this value, multiplying by this, and, doing all that kind of stuff. Binomial theorem helps you to shorten it, and it's really good for testing because that's what your teachers will definitely need for you to know. So like I mentioned before, binomial coefficient, that is the number of ways of picking k unordered outcomes from n possibilities. And these values are chosen from Pascal's triangle, which you guys probably already know about, but it's right here in the right-hand corner. And it's a list of values in which each value corresponds to the second value below it, because let's say, if you take level 5, which I have my cursor over, if you were to add 1 and 5, it would give you 6. If you were to add 5 and 10, 15, 10 and 10, 20, 10 and 5, 15, 5 and 1, 6. So each value makes the value below it. And each value always has 1 to begin it and 1 to end, as you can see. But anyhow, these values will be in this form, this nk, which is the binomial coefficient form. You don't have to put it in this. It's just kind of like another way where you'll get into, factors and factorizing with the exclamation part, a point of some sorts. You'll see that. But this is just this is just kind of a little bit more complicated. But if you know Pascal's triangle, you would know the value of this and how to add a coefficient on whenever you're doing a binomial expansion. Okay, so again, to practice, let's start off by, again, using our standard form, a plus b to the n power, where n will be a positive. So let's have x plus 3 to the 5th. Yes. Okay, so this is basically how we're going to do it. How to start. Now, logically speaking, if you were to look at this and you were to say, oh, well, x plus 3 to the 5th, x and 3 kind of look like they're together because they're in parentheses, and whenever you're dividing sort of values like that, they usually always stick together. But what happens is that for a binomial expansion to happen, they kind of have to be broken apart. They're still going to stay relatively close together, but it's going to, it wouldn't be, for instance, this. This could not be the answer. X plus 3, 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 because that's not right. Now, logically speaking, that would sound pretty good, because you're taking each of these polynomials to the 5th, just going it out, 5 of them. But this is what you actually do. So this is where it kind of gets a little confusing. What you do is you can either take your x or your 3. And this goes back to your standard form. You can either take your a or your b. And what happens is, I'm going to use a and b. Here's your a, is x. Here's your b, is 3. Your a is going to count down from your exponent, your given exponent. And in this case, we have 5. So a is going to count down from 5. It's going to go, as you can see, x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0. And your b, which is your 3, positive 3, is going to count up to 5. And you always, include 0 as your first counting number. So it's going to be 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4, and 3 to the 5. Simple. Okay, so you got that. We have this portion. This is a good portion. We have a good understanding. Now, you see these little numbers, like the 5, the 1, the 10, the other 10, and then the 5 and the 1 again. Those are your coefficients. So here's where we get into it. This is basically another step onto the 3 main steps of doing a binomial expansion. And what determines these coefficients is basically the Pascal triangle and the exponent that is given, the value of the exponent that is given. So let's go back. We know that our exponent is 5. Okay, so let's go back to our Pascal triangle and let's go to the 5th column. So this is our 5th column because we see 5, 10, 10, 5, 1, or 1, 5, 10, 10, 5, 1. And we know that this is our 5 column. Okay, so what we do, very simply, is we take these values and we insert it numerically in ascending order. So we have 1 right here, we have 5, we have 10, we have 10, we have 5, we have 1. Now, how do we get these values? This is the main question. There are 2 ways. I'm going to show you the basic one that I already kind of hinted at. If you were, like, let's say, given the Pascal triangle up to the 4th column, which is right here, and you needed to know, because you had a question like this one, and you needed to know the 5th. Easy. What you do, you start with 1, because automatically in the Pascal triangle, the rows start with 1 and end with 1. So we put our little 1 right here, and what we do is we look at the column above. Okay, so our last column is 1, 4, 6, 4, 1, and that's our 4 column. So what happens is this, we have our 1, then we add the above 1 and 4 together, and we get 5. Then we take that same 4 and add it to 6, and we get 10. We take the same 6, add it to 4, get 10, and we get the same 4, add it to 1, get 5, and we end with our 1, a separate 1. So basically, it's just a simple procedure of addition, and that's how you get each growth of a row, because you just add what's given before it. So in this case, we know that we have 1, 5, 10, 10, 5, and 1. Now, another way to do this is by doing this. We go back to here, our binomial coefficient of n and k, and what we do is we insert our value of 5, for instance, okay, and we insert it over 0 to get 1, and so on and so forth. So if we want to get the first coefficient, which is 1, again, we would insert 5 because that's our exponent value, as you can see, and we would put it over 0. Okay, so that's just little basic way, 2 little basic ways, but here is what we now do. Because we have the coefficients, because we have the kind of complete set, what we do now is we have to expand even more. So how we do this is we take our 3, for instance, that is counting up to 5, and not our x, because we can leave our x alone, and we simplify our 3 values, our 3 exponential values. So in this case, if we look right here, I've already kind of started it for us. The first one, which is this, all I've done is I've taken the 3 to the 0 and simplified it to equal 1. So the 1 is just I multiplied it with this, and I still got 1x to the 5th. I left the x to the 5th alone, and I multiplied this 1 by this 1. So for the second one, I did kind of the same thing, but instead of doing 3 to the 0, I did 3 to the 1, which is 3, and I got 15x to the 4, because I multiplied this 3 that I simplified for by the 5, and I got 15, and so on and so forth. So if you were to do, let's say, 270x to squared, how did I get this, is that I have, yeah, okay, this one, yeah. I have 3 to the 3, and I multiply that as simplified to the 10, and I get 270. So let's go and finish this one. This last one would just be 3 to the 5th times 1, x to the 0, and that would, because x to the 0 is just 1, we would already simplify that 1, multiply this one, and this one would multiply by the 3 to the 5th, and that would be 243. Now I have a practice page that you guys can be able to do, and I'm going to show you one of these because this kind of gets a little tricky. You see this one right here. You could do these because this is basically the same thing that I've been doing, but this one gets a little tricky in the case of you have a coefficient in front of your x base, and then you also have a different variable, but that's you have two variables, and then you have a coefficient, so that's a little tricky. But this is mainly how to do this one right here, the third one. So what you'd first start off doing, I kind of simplified it into two parts, because we already know how to start it off. We already know that we need two parts to each of our expressions. And we know that we're going to, this is our a value, and 2x is our a value, y is our b value, and 4 is what we are expanding, the exponent of 4. So what we need is we have a, and a will be counting down from 4, and we have b, and b will be counting up to 4 from 0. So I have that right here, as you can see, right here, and so on and so forth. And what I did is, because I know the 4, and it's in group 4 of the exponential value, I go back to my Pascal triangle and I look at group 4 and I have 1, 4, 6, 4, 1. So I just insert those coefficients right there, as you can see. And finally what I do is, before, oh, wow, sorry, I forgot to, made a big mistake. This is a negative. Okay, so if you're kind of getting confused why I have negative signs, yeah, that it's because it's supposed to be a negative right here. But this is kind of tricky, mainly because of the negative. So once we get all the coefficients in order and things like that, it would be easy, you know, just to kind of go ahead, start simplifying, doing that kind of stuff. But you must remember your sign change. And you can remember it by a pattern, but what's just easier is looking at your coefficient, starting to multiplying it, and writing it down on a scratch piece of paper, because to see it out on paper is going to be the best for you. Because this can, if this was a bigger exponential value and it had a negative, I mean, it would be 10 times as hard. So what we're doing here is we're basically taking 1 multiplied by 16, x to the 4, and y is non-existent because y is to the, well, it's not non-existent, it's y to the 0, which is 1, so I already just sub that in for 1, and I just multiply this by 16x to the 4, so it would give me positive 16x to the 4. So what happens then is I'll just do the same for my remaining unsimplified values, and I would get this total answer right here.